Okay, I've got an issue with the BMW whereby the battery doesn't hold up very well. It flattens over about 2 days to the point where you can't actually start the bike, which is pretty annoying. I've got a booster battery pack which I've used a few times, so that's the way I can get out of it, but it's annoying nevertheless. I swapped the battery, wrong one, swapped the battery not so long ago. I kind of just assumed it was the battery, and the battery I knew was at least 2 years old, more like 3. So I swapped it for a new one, and it's a proper brand. So I don't think it has any reason to be the battery, although of course it could have damaged the battery now if there's something else wrong. But anyway, my plan at the moment is to just take up the connections and work out what the quiescent current is. I've got a number of things on the bike. There's a tracker, there's a GPS tracker, which is continuously on, and I've got the INNOVV camera system with a camera at the back and the front. So that again will be drawing current continuously. And then of course there's the factory alarm, which I have fitted on this bike. That came as standard on this bike, so that's currently off, but I can try turning that on and see whether that makes any difference. Yeah, this one is the camera. This one is the charger. That just simply comes down to here to let me charge it up. So it starts off at 13 milliamps, drops to 4 milliamps. I'm expecting it to come back up to 70 or so. There we go. I suspect that's to say the battery being charged in the tracker. So if I leave that on for, I don't know, 10 minutes or so, I'd expect that to drop back to something reasonable once the battery in the tracker is charged up. I'd assume it must draw some current every once in a while as it connects and uses its SIM card mobile data connection to report back home, but it shouldn't be running a much current while it's idle and fully charged. Let's see. Okay, this meter has a storage capacity and a graphing capability, so just set that running. We'll see how long it takes to come back down to something reasonable, and whether that does tally up with it being the battery and the tracker charging up. Okay, so this has been monitoring the current draw primarily, I think, by the tracker, and sure enough, after about half an hour now, maybe 3/4, it's down to 4 milliamps. So I think that higher number that it was showing earlier is indeed just the charge of the battery. The tracker has an internal battery that it maintains by charging itself from the bike battery, so that if the bike battery is disconnected, then the tracker carries on running for at least some time. Okay, so I've just stopped that. See, yeah, so that's the stored data from the Fluke, and sure enough, after 27 minutes, just over, say 30 minutes, near enough, I mean, the current being drawn has fallen consistently in a sort of exponential way until it's cut off. So there's obviously something that's cut it off there, the battery charging circuit within the GPS tracker itself, and it's dropped right down to the milliamps. So yeah, okay, so the current draw from the tracker looks to be 4 milliamps once it's reached the point where the battery's turned off. So I'd guess that it kicks in every few hours to do a transmit back to home, but there shouldn't be any significant draw apart from that 4 milliamps. The INNOVV camera has 3 wires to it. It has plus and minus continuous supply, which is definitely what this fuse is doing. But it also has a switched positive supply, which is what is supposed to turn the camera on and obviously off when the power is removed. So my switch supply is currently connected to the tail light feed. So whenever the ignition is turned on, the tail light lights up. Then it applies power to the INNOVV switch lead, and they should turn on the camera. But when it hasn't got that additional switched line turned on, it should draw virtually nothing. But it obviously is drawing something, so yeah, I need to work out why that is. Right, so I've now just taken the fuse out of the feed to the camera, the INNOVV camera, and connected some the leads from the multimeter in there instead. And it's currently showing, with everything turned off, 11 milliamps. So that's quite a lot, really, I would have said. Okay, so let's turn it on and see what happens. Actually, I might as well record this while I'm at it. Save. Start. Okay, so I turn on the ignition now. And nothing happens. Oh, there we go. Camera's just turned on. I don't know if you can see the green light is on, so we're up to 278 milliwatts. It's trying to start up the Wi-Fi. GPS is searching. It's not going to find anything because we're indoors. Quite a lot of current though. 300, nearly 400 milliamps. It seems to be pretty stable. The same lights are flashing, the Wi-Fi lights, the recording light, and the GPS lights are flashing. So I guess that's its normal running condition. 300 milliamps. So let's turn the ignition back off and see what happens. So the ignition is going off now. So I think there's a delay built into the power supply, which leaves it on for, is it 20 seconds or 30 seconds? Oh, there we go, it's gone off. And what it's doing now, I guess it's writing to the card perhaps to just save anything that's in the buffer. At least the switching seems to be working. So when the live switch live supply is applied, it does turn the camera on, and when it's removed, it does indeed power the camera down. So that's good to know. So the camera isn't staying on all the time, at least. But we're still running at 30 milliamps. Is that going to fall, do you think? I don't think there's a battery inside the camera of any sort. I think it only takes its power from the continuous feed that it's got directly to the battery, or at least to the battery via the little power unit. Okay, the ignition's been off for about 15 minutes now, and we're still stuck at 30 milliamps. So that's not good, really. Just stop this recording and look at the graph. Yeah, so looking at this, the graph, this is it turning on. So it comes on almost up to 400 milliamps. Then when the ignition's off and the power module shuts down, drops back down to 20 or 30 milliamps and then just sticks there. So that seems to be the default current draw when everything's shut down. Interestingly, if I turn this off, I've got an override switch on mine. So that's the normal position, which I've labelled ride. Off is there, so I turn it off. Then, sure enough, the current drops to all but 0. If I turn it on, well, actually no, if I go back to the ride position, then interestingly it comes back on at 7 milliamps. So that, oh no, hang on a minute, coming back up. Is it going to rise back up to the 30 that we had before? No. So that's quite strange behaviour, isn't it? It's if it's been running with the bike running, as it's running, it's drawing 300 milliamps, maybe 400 milliamps. When you turn off the ignition, stop the bike, it shuts down to something like 30 milliamps. But for some reason, if you power it off and back on again, or disconnect it from the battery and back on again, it comes on at 11 milliamps. So it's drawing 3 times as much current after being used in real life, kind of thing, versus being just powered on from cold independently of the bike. Right, so I've measured the INNOVV camera draw at 30 milliamps, kind of maximum, hopefully 10 milliamps when it's in idle mode. The tracker looks to be like 7 milliamps. So say we're talking 40 milliamps, then a 10 amp hour battery, which is something like 10, either 10 or 12, that's what, 250 hours? So it should be able to drive those loads for days rather than, was it more than a couple of days that it seems to be working at the moment. So maybe the battery is faulty. I'll just check the drawer on the battery with everything connected again, and maybe try it with the bike alarm as well, and just see how that goes. Yeah, that's with everything on. That's with the camera on and the tracker and the ignition off. So again, that should last for a long time. Shouldn't be a problem in terms of the battery going flat within a few days. But while I'm here, let's try the ignition on now. What happens? Yeah, straight up to 6 amps. I'll try and turn off the alarm if I can remember how to do it. Okay, so that's got the alarm on now. Yep, the alarm is flashing on the dash, the red light that just lets you know when the alarm's on. So this is settling back down again. Goodness knows what's going on now. 1.7 amps going somewhere. Oh, the indicator has just flashed to indicate that the alarm has armed itself. Okay, so it's been probably 10 minutes since I turned the ignition off, and we're down to 14 milliamps. So that's probably, well, that suggests that the factory alarm is not taking a lot at all. It's yeah, certainly in the milliamp range. So that isn't the cause of any significant drain on the battery. Yeah, so as I say, the battery is a good quality one, as far as I know. 11.8 amp hours. UARSA, so it should be fine. Looks okay, no bumps or cracks. So it's only about 18 months old, perhaps. Can't see a date stamp on it anywhere. But yeah, I did replace it not that long ago. So let's just whack it on charge with the Optimate for a start, and then I'll discharge it and see what that shows. For a start, I'll just try this cheap and cheerful test charge just out of curiosity, really. Oops. There you go. So, testing. 100% healthy, 245 cold cranking amps, 98% charge, 12.87 volts, internal resistance 12.04 milliohms. So good. So that's interesting. So this is a Teco 6 charger you can get off eBay easy enough. Powered by USB. Just connect it up. So 6 volts. It'll discharge at 1.2 amps until it reaches 6 volts and it'll stop. So that should start it, I think. There we go. Fan started up. Basically, it just dumps the energy in the battery through a MOSFET, I think, and monitors the current and the voltage and keeps a tally of the amp hours, milliamp hours. So we're on milliamp hours now, or amp hours rather. So it's 8 milliamp hours so far. So that should take about 6 hours to discharge or so. So I'll leave that running and see how we go. Okay, so this Teco 6 battery tester has finished and it's showing 6.368 amp hours. So yeah, not the spec it should be, but it's not completely dead. I mean, it's probably pretty good. I mean, that's like half what it should be, pretty much, just over. But even so, I don't think that's bad enough to cause the problem that I've been having. But there again, well, no, it would last rather than 250 hours. It would last 125, which is, I suppose, only 4 or 5 days, isn't it? Yeah. Disappointing if this has failed after probably 18 months. Still, I'll put it in for now. Put it back in. I'll charge it up again. Put it back in and see how I go. So the Optimate showing that it is pretty bad. Not that surprising. I think the LEDs on the Optimate, this save one, comes on if the battery is less than 40% charged, and it does this desulfation cycle, or a program, and then it'll move across to the charge and finish off the bulk charge. So by tomorrow morning it should be fine. I'll stick it back in the bike. Okay, so it's the following morning now, and it's charged up. Optimate showing it as good. So I'll stick it back in the bike. Yeah, sort of I learned, not a lot really. And the battery's not 100% by looks of it, but it's good enough. Should be fine to run for another year or so. The draw from the various accessories on the bike doesn't seem to be enough to explain the loss of juice that stops me starting it after 2 or 3 days. So yeah, I don't know. If anybody's got any ideas, I'd be pleased to hear them. But otherwise, I'll just press on regardless, I think. Make sure I'm carrying the booster battery and use that to start when I need to. Okay, thanks for watching.